So, in this experiment, we're going to be learning about some discoveries related to the atom. If you look at this picture, there's a famous scientist named Ernest Rutherford. The first part of the experiment will simulate a famous experiment that Ernest Rutherford used to help him develop a better model of the atom. So, before Ernest Rutherford, scientists described the atom as a sphere, like a marble or a ball, that was composed of positive and negative charges that were mixed together. They thought that all elements were made of many of these spheres. Since atoms of each element are different from each other, the sphere for each element would be slightly different. So there are some parts of that description that are true, like the presence of positive and negative charges, and the fact that atoms of each element are different from each other. Rutherford set out to test this model of the atom using alpha particles. So alpha particles, like you see here, are just small nuclei that are emitted from a larger atom during decay. Technically, they are the same as the nucleus of a helium atom if it didn't have any electrons. He was able to shoot these alpha particles at a material, in this case gold foil, and he used the results of his experiment to help him understand the atoms that made up the gold foil. These alpha particles are small enough that they can pass through things like paper or foil. There are also smaller particles and waves that are also described as radioactive, and those would be beta and gamma. You can see some examples here, but his experiment used alpha particles, which are technically the largest of the three. So in Rutherford's gold foil experiment, you can see a diagram here at the bottom. He used a sheet of gold that was very, very thin, only 2 to 3 atoms of gold thick. He had a radioactive source that he could use to shoot alpha particles at the gold foil. And what he noticed was that nearly all of the alpha particles would pass directly through the gold foil as if it wasn't there. But a small number of the alpha particles were deflected. And so to deflect means that its path bends, so they went off in a different direction. Some of them a little bit, and some of them back towards the scientist. What he learned from that experiment was that even though the gold foil appeared to be solid, and the previous understanding of atoms was that they were solid, that actually the atoms were mostly made up of empty space. So if we look at this picture of Rutherford's atom at the top, we can see that it has a small dense nucleus, but that the electrons are orbiting out here in the space that surrounds the nucleus. When he shot alpha particles at the gold foil, most of them passed through the space that's between the nucleus and the electrons, but some hit the nucleus, and that would cause them to be deflected and bounce back towards Rutherford. So in our experiment, you're going to be simulating the Ernest Rutherford experiment using some simpler materials that we have in class. Watch the video where I demonstrate the experiment so that you can better understand what you need to do.